Question number 6. I have two polynomial functions, and my first task would be to determine the expression for each function. For f of x, it's very easy. It's a first-degree polynomial. In other words, a linear function, y equals mx plus b. B is the y-intercept given to me here, and the constant rate of change, in other words, the slope, is 4. So I can directly conclude that f of x equals 4x minus 4. For g of x, it's a third-degree polynomial, and the 3 zeros are given to me here, so I can directly conclude that g of x will be a coefficient a that I don't know yet, times x plus 4 times x plus 1 times x minus 1. And here I do recognize for those two the factored form of the difference of two squares. So I'll have x squared minus 1 times x plus 4. And I need to find a. And for that, I'm going to use the point given to me here, which happens to be the y-intercept. So g of 0 equals 8. So I'm going to replace the x here and there by 0. And I will have a times negative 1 times 4 equals 8. In other words, I will have negative 4 times a equals 8, which is equivalent to a being equal to 8 divided by negative 4, negative 2. And so g of x would be equal to negative 2 times x squared minus 1 times x plus 4. Now, for the following of the problem, what I will do is to distribute everything. That will make things a little bit easier. So I'm going to first distribute the x squared. I will have x cubed plus 4x squared. Then the negative 1. I will have negative x and minus 4. And if I distribute the negative 2, I will have negative 2x cubed minus 8x squared plus 2x plus 8. And finally, to find the intersect of between f of x and g of x, between their graphs, I need to solve g of x equals f of x. So I will have negative 2x cubed minus 8x squared plus 2x plus 8, which will be equal to f of x, which is 4x minus 4. And here I notice that all coefficients can be divided by negative 2. So I'm going to do that right away. I'll have x cubed plus 4x squared plus minus x and minus 4 equals negative 2x and positive 2. Now I'm going to put everything on the left side, and I will have negative x plus 2x, which is positive x, negative 4 minus 2, which is negative 6. So I need to solve that polynomial equation. And to do so, I'm going to use the rational zeros theorem. I'm going to identify P as an array constituted of 1, 2, 3, and 6, referring to the constant here. Q would be just 1. And therefore, the possible rational zeros would be as followed: plus or minus 1 over 1, plus or minus 2 over 1, which is 2, and so on, plus or minus 3, plus or minus 6. Now, I'm going to take the coefficients of these polynomials, so 1, 4, 1, and negative 6. So 1, 4, 1, and negative 6. And you have to try out all those possible rational zeros until you have one that works and that gives you a remainder of 0, and then you will be able to use the factor theorem. So here I've done it just before, so I know that 1 is working. 1 plus nothing is 1, times 1 is 1, plus 4 is 5, times 1 is 5, plus 1 is 6, times 1 is 6. So I can directly conclude that g of x equals f of x is equivalent to x minus 1 times x squared plus 5x plus 6 equals 0. So what I just did here is simply factoring this side of the equation. Now I can factor further and have x minus 1 times x plus 2 times x plus 3, and therefore the possible values of x will be positive 1, negative 2, and negative 3. Now, it's asking the intersects. These are points, so I need to get the y coordinates. So I could use g of x or f of x, but I'm going to use f of x because it's just a linear polynomial, right, of the first degree, 4x minus 4. So in that case, that's my next step. F of 1 would be equal to 4 minus 4 is 0. F of negative 2, negative 2 times 4 is negative 8, minus 4 is negative 12. And f of negative 3, 4 times negative 3 is negative 12, minus 4 is negative 16. And therefore, the intersects will have those coordinates. So a fancy way to express this solution to conclude would be to say that the intersect between this graph and that graph will be equal to the following set of points: 1, 0, negative 2, negative 12, and finally negative 3, negative 16. Now, of course, I'm not expecting you to conclude in that fancy way, but I'm counting on you to be precise and clear. And that's it. Good luck.